This screencast is a follow-up to the screencasts that I have already created regarding the supermassive black hole at the center of the Milky Way galaxy, and also that of the supermassive black hole at the center of the galaxy M87. So this screencast is a follow-up to those screencasts. This screencast is being created in the summer of 2022. This is after the monster of the Milky Way, Sagittarius A Star, the supermassive black hole at the center of the Milky Way, has been imaged by the Event Horizon Telescope. So let me go ahead and start this screencast here in the following manner. Okay, so as I've already shown you in class or in my screencast previously, this right here is a radio image of the black hole at the center of M87. This radio image was taken in 2019, and it was taken by the Event Horizon Telescope. The image of the black hole itself was created by linking together radio telescopes. That's right here. Radio telescopes that are scattered around the world. Scientists then and engineers use a technique called interferometry to combine the data from these individual radio telescopes, this network here, into a single image. So the radio telescopes are electronically linked. This network of radio telescopes, as you can see, is worldwide, and this technique called interferometry enables the telescope to act as a single telescope with a size that is equal to the network itself. So because this is a very detailed engineering project, in order to obtain these images of these supermassive black holes, a tremendous amount of data must be obtained by each individual radio telescope, and then they are all electronically combined together. Okay, so right here is Sagittarius A Star, the monster of the Milky Way. This is the supermassive black hole that's at the center of the Milky Way. The diameter of the event horizon, which you can see right here, is about 0.2 AU. And the various colors that you could see here are a depiction of the swirl of dust and gas emitting radio waves near the event horizon of the black hole. Okay, the location of Sagittarius A Star with respect to the Earth is about 27,000 light years away at the center of the Milky Way. Here's a nice simple drawing of the barred spiral structure of the Milky Way galaxy and the location of Sagittarius A Star. And then, as previously described in class, the Earth and the solar system more or less are on the inner edge of what is called the Orion Arm, which is a distance of about 27,000 light years from the monster of the Milky Way, from Sagittarius A Star. Okay, now let's compare the two supermassive black holes to each other. Okay, as impressive as Sagittarius A Star may be, it pales in comparison in terms of its size to M87's supermassive black hole. So right here in this little graphic, right here, for example, is Sagittarius A Star. So that is this image right here. And then M87 is this right here. Sagittarius A Star is 1,000 times less massive than the black hole of M87. So this then means that the event horizon of M87 is absolutely gargantuan compared to that of Sagittarius A Star. So this last image here is a nice depiction of this comparison. So here on the right-hand side, right at the center, is the sun's diameter. And then right here is the event horizon of Sagittarius A Star. And this right here then is the swirl of dust and gas around the event horizon. For comparison, right here is the orbit of Mercury. But then take this entire box here representing Sagittarius A Star, and it fits into a tiny point right here at the center of M87's black hole. For reference, this right here is Pluto's orbit. So you could see, for example, that right here the event horizon for M87's black hole is considerably larger than our entire solar system. Also, for comparison, this right here is a depiction of the location of Voyager 1, which was an interplanetary space probe that was launched by NASA back in the late 1970s. It's currently headed outwards from the solar system in interstellar space. Just for reference, its distance from the sun is about like so, and it is still smaller, as you can see, than the diameter here of the event horizon for M87's black hole. Okay, so that concludes this short screencast describing these two black holes.